Welcome to this presentation on the top Java interview questions. Throughout the next slides, we'll explore key questions that often come up in Java interviews, helping you prepare effectively. This content has been carefully put together by javatovictory.com to give you clear insights and practical knowledge. Whether you're new to Java or looking to sharpen your skills, this guide will help you understand important concepts and how to answer questions confidently. Let's get started and take a closer look at what you can expect in Java interviews. The JDK, JRE, and JVM are closely related but serve different roles in Java programming. The JDK, or Java Development Kit, is what developers use to create Java applications. It includes tools like the compiler and debugger. The JRE, or Java Runtime Environment, is what you need to run Java programs. It provides the libraries and components that the application relies on to execute. The JVM, or Java Virtual Machine, is a part of the JRE responsible for actually running the Java bytecode, making it possible for the same program to run on different platforms without modification. In short, the JDK is for building Java applications, the JRE is for running them, and the JVM is the engine that executes the code on any device or operating system. When comparing objects in Java, the == operator checks if both variables point to the exact same memory location, meaning they are the same object instance. On the other hand, the == method looks deeper by comparing the actual content or values inside those objects, such as the characters in two strings or the numbers in two wrapper objects. This distinction is important because two different objects can hold the same value but reside at different memory addresses, so == would return false while == would return true. Understanding when to use each helps avoid bugs, especially when working with objects like strings, where value equality is often what you really want to check. HashMap and Hashtable both store key-value pairs, but they differ mainly in synchronization and performance. HashMap is not synchronized, which means it's faster but not thread-safe when used by multiple threads at the same time. It also allows one null key and multiple null values. On the other hand, Hashtable is synchronized, making it thread-safe, but this comes with a performance cost. Additionally, Hashtable does not allow any null keys or values. So, if you need a collection that works well in a single-threaded environment or where synchronization is handled externally, HashMap is a good choice. But if you need built-in thread safety and don't require null keys, Hashtable might be better. Java Collections is a framework that offers a variety of data structures such as list, set, and map, which help manage groups of objects more effectively. Instead of dealing with individual elements, these structures let you store, retrieve, and manipulate multiple items in a way that's both organized and efficient. For example, a list keeps elements in order and allows duplicates, a set stores unique items without any particular order, and a map pairs keys with values for quick lookups. Using collections simplifies many programming tasks by providing ready-made tools that handle common data management needs, so you don't have to write complex code from scratch. Garbage collection in Java is a process that automatically frees up memory by removing objects that are no longer being used by the application. This means developers don't have to manually manage memory, which reduces the risk of memory leaks, situations where unused objects stay in memory and cause the application to slow down or crash. By cleaning up these unused objects, garbage collection helps keep the application running smoothly and efficiently, improving overall performance without extra effort from the programmer. In Java, the terms final, finally, and finalize serve very different purposes. The keyword final is used to declare constants, methods that cannot be overridden, or classes that cannot be subclassed, ensuring that their behavior or value remains fixed. The finally block is part of exception handling and always executes after a try-catch block, allowing you to run cleanup code, like closing files or releasing resources, regardless of whether an exception occurred. Lastly, finalize is a method that the garbage collector calls before reclaiming an object's memory, giving the object a chance to clean up resources, although its use is generally discouraged in favor of other resource management techniques. Understanding these distinctions helps write clearer and more reliable Java code. Multithreading in Java lets multiple threads run at the same time, which helps improve the overall performance of an application. This is especially useful for tasks that can be done in parallel, like processing large amounts of data or handling multiple user interactions without making the application feel slow or unresponsive. By allowing different parts of a program to execute simultaneously, multithreading makes Java applications more efficient and responsive, which is why it's commonly used in various types of software development. Spring Boot offers a significant advantage over traditional Spring by simplifying the setup process. It comes with default configurations and includes embedded servers, so you don't have to spend time configuring everything manually or setting up an external server. This reduces the amount of boilerplate code you need to write, which means you can focus more on developing your application's features. Overall, Spring Boot speeds up development and makes it easier to get a project up and running compared to using Spring alone. Microservices architecture divides an application into small, independent services that each handle a specific function. These services communicate with each other through APIs, which allows them to work together without being tightly connected. This approach makes it easier to scale parts of the system as needed, update or fix individual services without affecting the whole application, and adapt quickly to changing requirements. By breaking down a large application into manageable pieces, it also simplifies maintenance and development, especially in complex projects. This is especially relevant in Java, where combining microservices with frameworks like Spring Boot can speed up building scalable and flexible systems. In Java, exceptions are divided into two main types: checked and unchecked. Checked exceptions are those that the compiler requires you to handle explicitly, either by catching them with a try-catch block or by declaring them in the method signature. An example of this is IO exception, which often occurs when dealing with input and output operations. If you don't handle these exceptions, your code won't compile. On the other hand, unchecked exceptions happen during runtime and aren't checked by the compiler. These include exceptions like null pointer exception, which occur when your code tries to use an object reference that hasn't been initialized. Because unchecked exceptions are usually due to programming errors, they don't need to be declared or caught explicitly, but you should still write your code to avoid them whenever possible. Understanding this distinction helps in writing more robust and maintainable Java applications. Thank you for following along with this Java interview preparation series. If you want to dive deeper and practice more questions, you can visit javatovictory.com, where there are plenty of resources to help you strengthen your understanding and get ready for your next interview. I hope these explanations have been helpful and give you more confidence in Java concepts. Good luck with your studies and your interviews ahead.